You're listening to the Common Descent Podcast. Hello, Will.
Hello, David.
And hello, Ranjeev.
Hi, guys.
Welcome.
Welcome and hello to our listeners. Welcome back to our special Common Descent Spotlight mini-series. As you know, if you've been listening up to this point, this series we break from the normal format of chatting about particular scientific topics and instead focus on some scientific people. Over the mini-series, we've been following the theme of invertebrate paleontology. This is the fifth of 5 in this series, and for our final episode, we are joined by invertebrate paleontologist Ranjeev Epa. Would you please introduce yourself to the listeners?
Sure. I'm Ranjeev Epa. I'm from Sri Lanka, which is a very beautiful country just to the south of India. I got my bachelor's degree in zoology from the University of Peradeniya in Sri Lanka. I got my master's in geology from Ohio University, and I just started my second year in my PhD program in geology here at the University of Missouri in Columbia.
Excellent. And your master's advisor was Dr. Alicia Stegall, correct?
Yes, she was my advisor.
She was our guest in episode 3 of this series, so there's connections there. Now, we love starting these series off by talking about the invertebrates that our guests study. And you, we know, are a big fan of bivalves.
That is correct.
So can you start off by telling our listeners what are bivalves?
Certainly. Bivalves are mollusks that have 2 valves. They belong to the class Bivalvia, which is the second most diverse class within the phylum Mollusca. So we have about 10,000 living species of bivalves at present. So we find bivalves in marine, brackish water, and also in freshwater settings. If you look at bivalves in the modern, you can see a range of sizes and shapes of bivalves. Talk about the shapes, you get bivalves that are perfectly oval in shape. We get bivalves that are broadly triangular, and in the case of oysters, their outline is very variable, and it may depend on factors like the substrate and the degree of crowding as well.
So oysters are an example of bivalves, and then clams and mussels, all the delicious stuff.
Yeah. Yes. If you talk about their size ranges, the smallest bivalve is a species of nut clam, Condylonicula maya, and the adult is about a half a millimeter in length.
Wow.
Wow.
I know, right? So, and the largest bivalve, the giant clams, Tridacna gigas, they can reach a length of about 4.5 feet. So they're huge. So got a broad range in terms of size.
Wow, big enough to eat a child.
Yes.
Right.
Well, I guess not eat a child. They're filter. Are all bivalves filter feeders?
Not really. A majority of them are, but we also have bivalves that are carnivorous. So bivalves have siphons, tubes which they use to bring in the water. So these carnivorous guys have one of their siphons modified into a cup-shaped structure so that they could bring in their potential prey. So they're very interesting. Bivalves are very, very interesting.
Oh, that's cool.
So as I mentioned before, bivalves have 2 valves. Let's call them shells, right? So these shells are actually made out of calcium carbonate. And there are actually 2 polymorphs of calcium carbonates that bivalves use to build their shells, aragonite and calcite. So depending on the species, they would either use aragonite or calcite or a mixture of both. So the shell is actually made out of different layers. The outermost layer is an organic layer, which we call the periostracum. And towards the interior, we have the calcareous layers. And depending on the species, the number and the microstructure of the inner layers do vary. If you guys have looked at like bivalves in real close detail, you'd see that some bivalves have like very interesting sculptures on their surface. So some of them are radially distributed from the dorsal part of the shell, and some are parallel to the ventral margin. So these ornamentations are thought to be advantageous for bivalves in burrowing and stabilizing them.
Oh.
But also they've been interpreted as anti-predatory traits as well.
So they're spiky and ridged. I'm thinking like an oyster.
Right.
Helpful for burrowing, but also conveniently makes you not very palatable.
Yes. So we have bivalves with spines. So if you look at spondylus, I think it's called the thorny oyster, they have very prominent spines. There's a hypothesis behind that suggests that helps as an anti-predatory trait, but also as a surface for epibionts to lay on, so that they provide the bivalve with very good camouflage from the predators.
Okay.
Oh, excellent.
Makes it a rougher surface for those to attach and everything.
Exactly. Yeah. Exactly.
Oh, cool.
So now, whenever I think of bivalves in terms of fossils, and we mentioned this earlier in this series, I always think of bivalves and brachiopods together because they're the classic two-shelled invertebrates. Now, in episode 3, when we talked to Alicia, she held up brachiopods as the best of the shelled invertebrates and put down bivalves a little bit. Would you like to respond to that?
Well, when I joined her lab for the first time as a grad student, one of the first things that she told me is brachiopods are the best animals ever, and they rule above all the other animals. So being a shell collector for like 30 odd years, I mean, they do look like bivalves, so I'm okay with that. But yeah, well, looking at the modern, I would stick with bivalves because they're prettier. They have beautiful color patterns. Yeah, I just love bivalves. I do love brachiopods. I love fossils. I love any fossil, but I would go with mollusks as the best.
Ooh.
All right, you heard it here, folks. we have an invertebrate debate. Okay, so you do more than admiring bivalves. They're also the center of your research. Can you tell us what's your research about?
So at present, I'm working on a research project where I look at biotic interactions that are recorded on the shell surface. So if you think about it, like every seashell has a story to tell about what happened to them when they were living and what happened to their valves when they died. To read the story, you got to look at the shells real close. So there are some traces on a shell of a bivalve that you can interpret as live interactions as opposed to post-mortal interactions. So my research at present is focused on looking at live interactions on a massive collection of Pleistocene fossils of Florida. So I think I have about 15,000 shells.
Wow.
I sipped out 10-liter bucket full of shell material over the break. So I got a lot of shells to play with. So
just a few.
Just a few. So what I'm doing is I'm looking at basically 3 types of interactions: predatory drillings, trematode-induced shell malformations, and polychaete-induced shell malformations.
Now, when you say predatory drillings, there's an activity that Will and I do it now again that I'm back, and we both used to do at the museum we worked at with marine fossils from the Aurora site in North Carolina, and we'd get these little bivalve shells with these perfectly little round holes through them. Mm-hmm. That sort of thing?
Yes, exactly. So There's a unique set of predators that are able to drill into shelled animals like bivalves and snails, and they're able to feed on the internal tissues. But if you look at a bivalve or a snail, you'd see that they are littered with holes, like after they died, obviously. They're littered with holes. So you got to be able to differentiate between a predatory drill hole versus a non-predatory hole, which like some of the sponges like Cleona would produce, which are burrowing, which they use as like their house. So there are like several criteria that needs to be met to be for a drilling to be classified as a predatory drill hole. The first one is like there should be only one drill hole per prey animal, just one.
Makes sense.
We do have very rare occasions where we have two, but just one. That's the rule.
Okay.
Then the size of the drillings should have a specific shape, which would depend on the predator and the prey to some extent. The size of the drillings should be within a narrow size range. The drillings should always be made perpendicular to the valve surface, and the drillings should be from the outside to the inside. And typically, drillings should show a non-random distribution on the surface of the prey, so that we know this is biological as opposed to something taxonomic.
Okay. And what sort of predators are these that are attacking these clams?
In the modern ecosystem, we have two dominant drillers. Both of them are snails. We have the moon snails, family Noticidae, and we have the muricid snails, Muricidae, which are the dominant drillers today.
Very cool.
Drilling process itself is a combination between mechanical rasping and chemical dissolution.
Oh, so they're because snails have the raspy radula scraper tongue.
Right.
And they're using that as a drill, but they're also dissolving.
Yes, these snails have something called the accessory boring organ. So they're able to produce acids that dissolves the shell. So
man, that makes it so much worse for the bivalve. Like the idea of getting drilled into is bad, but now it's like you just zzz, and then that's awful.
But I get a chance to look at drill holes, which I love. And interestingly, if you look at the history of predation, drill holes are the first evidence of predation like ever. So there are these Precambrian tubular fossils called Claudina. They have within themselves like tiny drill holes, which are interpreted as predatory drill holes.
That's cool.
That's awesome.
Now, you said in your research you're seeing predation evidence, and then you also said malformation,
right,
from a couple of sources.
Right. So I look at trematode-induced malformation. So trematodes are parasitic flatworms. They use bivalves as either their first or second intermediate host. So when they use them as the second intermediate host, there's a stage called the metacercaria stage of the parasite. They are able to produce a shell malformation, actually two shell malformations. One is a oval-shaped pit with a very prominent rim around it, and another which we call as an igloo structure. It looks like an igloo, so it got like a blister with a narrow opening at one end. So these are very diagnostic to trematode-induced malformations. So I look at those as well, and I look at malformations caused by polychaetes. So polychaetes of the so there's a family of polychaetes called the Spionidae. So these guys burrow into shells. They're not predatory; they just use that burrow as their home. But if they happen to penetrate an area of the shell which we call the extraperioral space, which is the area between the shell and the mantle. The host react by secreting shell layers to wall off the intruder, so which results in an elongated blister, which we call as a mud blister, which may include mud, worm feces, and sometimes the worm itself. And these are preserved very nicely in the fossil record.
Wow,
that's awesome.
It's like literally a time capsule. That's
Exactly.
really wow.
So I'm picturing the every now and then you'll see a tree that has a branch, a really thin branch with that bulge in the middle where some kind of insect has parasitized it and it changes the shape.
Right.
So you're seeing that in your shell.
Yes. So if you
that's really cool.
So in the case of the polychaetes, if you flip the shell over to see the outside of the shell, just close to where the mud blister is, you might see a very nice paired holes, which resemble the number 8, which shows the entry and exit of the worm.
Huh.
Oh,
that's cool.
Wow. Now you said you're looking at Plio-Pleistocene fossils, so 2 or 3 million years old.
Yes,
I presume.
Yes, I think it's a little bit older than that.
And what are you hoping to discover?
So, I mean, if you look at literature, there's been a lot of work done on predator drill holes, but not so much on trematode parasitism, and not so much on polychaete malformations either. So what I want to see is if there's like any taxonomic selectivity or some sort of factor that contributes into some species being having a higher prevalence of any of these traces. So that's at a broader scale. That's what I'm looking at. But I still have a lot more shells to work with, so I'm pretty sure I'll come up with. Every time I see a weird trace, I develop several new hypotheses in my head. So it's really interesting because you never know what you're going to find when you look at a shell. And once you find something, you got to use all your knowledge and try to figure out what this is. It's like very rewarding when you find a parasitic pit. I know it's not for the clam or the bivalve, but for me, it's very rewarding. So.
I'm fond of saying that good paleontology is based on past tragedy. It's the worst day for the clam, the more interesting for us.
I agree. Sad. It's sad, but it's true.
Now, the predation and the parasitism that you're seeing in these ancient bivalves, how do they compare to what you see today? Is it similar structures? Are there any things you see in the fossil record that you don't see today?
Well, we're going on, we're using the modern as a good starting point. So the structures we see are quite similar to what we see in the fossil record. So there's not a lot of difference. There've been past research done on how the placement of drill holes migrated over time, but more or less from my experience, what I see in the modern is pretty much what I would see in the fossils as well. So,
okay. One of the recurring themes that keeps coming up, hence the word recurring, David, is this pattern where invertebrate paleontologists end up with a lot to work with.
Yes.
And you said you have 15,000 shells to look at.
Mm-hmm.
We've mentioned this in previous episodes of this series, of the Spotlight series. That's ridiculous. That's the kind of thing you only get with invertebrates.
I was expecting you to say like maybe 100, 1,500.
Well, the more samples I have, the happier I am.
Yes. It's one of those big differences between invertebrate paleontology and vertebrate paleontology, where we're happy to get, at the Gray Fossil Site, we were thrilled to find one mastodon.
Yeah.
Like, that's incredible. How could you hope for more than that? And you have 15,000 of your study specimen, which is really cool.
I agree. I love what I do. I spend a lot of time in the lab, and sometimes my friends have to ask me to leave because I spend literally hours and hours in the lab.
The thing that I'm always impressed by with this kind of research that has such a rich supply of specimens is that you get that nice spectrum of all the different views and all the different cases. And that's really cool because you get, with fossils, it's never the complete picture, but you're getting a really solid image, and that's awesome.
Yeah, lucky for me, bivalves have a very good potential for preservation because of their hard shell, and to some extent their infaunal ecology as well. So,
excellent. Is there anything else you wanted to say about your research?
I could say one other thing. So,
Sure.
I first saw a predatory drill hole when I was 3 years old. I had no idea what that was, and it took me about 20 years to figure that out. But the moment I saw that drill hole, I knew like this is going to be an awesome trace, and I would really love to know what this is. And today I'm working on that.
That's awesome.
That's awesome. That's fantastic.
That's what you want to hear.
I think the first time I ever saw a predatory drill hole, I assumed someone's shell necklace had broken.
Yeah,
I thought it was a bead, a shell that had been made into a bead.
Well, it's interesting that you said predatory drill holes almost always show up one hole per shell, which means some of the things that I've been seeing in that Aurora stuff that I thought were drill holes are not. Because I've seen shells with like 100, not 100, but a whole bunch, a lot of little drill holes in them.
Those are probably the result of a boring sponge. A predatory, a drill hole that is being drilled by a moon snail would have a distinct profile. So it would have what called a countersunk profile. So you'd have an outer drill hole and an inner drill hole. The inner drill hole is like smaller than the outer drill hole, and the walls are curving, like they're parabolic, so they're curvy.
Oh, cool.
And the Muricid drill holes are like straight walls. So you got the outer drill hole, and they drill like straight down. So it's a straight wall drill hole as opposed to the moon snails one. So they've been given different ichno species names as well. So the drill holes drilled by moon snail, which has that profile, is referred to as Oichnus parabolides, I think, and the Muricid ones are called Oichnus simplex. Surprisingly, they've also found drill holes that have been drilled by octopi as well. So those are called Oichnus ovalis. They are like much more, I think they are more oval shaped, and they have like this weird gutter that runs.
That's awesome. So I don't know much about different kinds of sponges. I did not know that there were burrowing sponges that would drill holes. Are these sponges aiming for bivalves, or is it more like happenstance that they're just drilling through the shell as they're...
They just just burrow into these shells. I think they use them as like a house.
Oh, interesting. If I send you pictures of these shells that I see with holes in them, can you tell me what drilled them?
Sure.
I am definitely going to do that. That's awesome. We're making connections here on the podcast. So one note I wanted to make for people who have listened to other episodes of our podcast, we've talked about ichnospecies before. The notion that you don't know what made your drill hole or footprint exactly, so you give a species name to the trace.
Exactly. We are not concerned about the trace maker. We just focused on the trace itself, because a single organism can produce multiple traces and vice versa. So if we think about the trace maker, it would really confuse the thing.
So let's talk a bit about your experience as a graduate student. So you're a PhD student now.
That's correct.
At the University of Missouri.
Mm-hmm.
What is your department like? What is the paleontology program like?
Oh, it's awesome. I love it there. So a bit of a backstory. So I've been a grad student since 2015, so it's almost 4 years now. Because I'm an international grad student, I was very nervous coming here because I'm moving to a new country. going to be away from my friends and family for a long time. But what worked for me is like I had a perfect environment. What I mean by that is I had two wonderful advisors, both at Ohio University and here at the University of Missouri, were wonderful people who were doing research that I was like truly interested in. And I chose the right research for me. So when I go to work, I actually don't feel like I'm doing work. I feel like I'm doing something that is much more relaxing. And that's why I spend a crazy amount of time in the lab. I also made a lot of cool friends from different countries who've been like helping me throughout my stay here, which is very important for international grad students. I also had an added advantage of my wife and my brother being here in the US, which always helps to have family close by. One of the most important things that happened to me in my grad life was meeting researchers that I've been idolizing for a long time. So about a year ago, I got a chance to meet Professor Patricia Kelly, who's like this towering figure in research in drilling predation. I had a fantastic discussion with her. I also got a chance to meet Professor Neil Shubin when I was in Ohio. So the list goes on. So that's like one of the rewarding moments of my program so far. I must say one thing that when I applied to a geology program, I was extremely nervous because my undergraduate degree was in zoology and I had never taken a geology class before that. So I was wondering if how I'm going to do this. So what the graduate programs at both Ohio and here at Missouri were structured in a way that apart from us taking advanced courses, we had room to take classes that would help us in any deficiencies we had in geology or in any other field. So I really benefited from that, and it helped me very much in my progress. With my experience of being in both these programs, I would like to take this opportunity to recommend the geology program at Ohio and here at the University of Missouri to anyone who's interested in learning paleontology, because I know from my experience that I benefited a lot from these programs.
I sympathize with you completely. I had my undergrad was biology, and my school actually did not have any geology courses. It was a small little college. So I wouldn't have taken them had they been available probably either, but I did not have the option. So I was complete bio, focused on the animal stuff when I got into my master's program as well. So I had to brush up a bit more knowledge on the geological side of things.
I mean, it's like so when you do biology, you know how to think like a biologist. Now, once I take in geology, now I know how rocks think about stuff. So imagine, so what would a rock do? Kind of like that thing. So you get a complete idea, a broad idea. And so once you're able to speak geology, I mean, that gives you a lot of tools to work with, especially as a paleontologist. And you kind of need both biology and zoology. Biology and geology. I'm really glad I came into a geology department. And as I said, I benefited a lot from the graduate programs at Ohio and here at Missouri.
PhD programs are notorious for, if you're on Twitter or anywhere on the internet, people there's a lot of, stories of stress and lots of work in PhD programs. What is it like to be a PhD student?
Well, I actually love what I do. So my overall goal is to become a teacher. So you kind of need a thorough understanding of your field in order for you to become a efficient teacher. As a PhD student, I enjoy my classes and I enjoy my research. If you don't love what you do, it's not going to work out. So I know a PhD student, like typically they'll say that they'll have a lot of work. I mean, it is true, but if you love what you do, I don't think you would feel that there's a lot of work to do. I mean, every morning, like when you wake up, you are so excited to go to your office, to your lab. I mean, the first class I took at Ohio was on ethnology, and this is like that. I loved it so much that I was really sad when it was over, to say. Yeah, if you're excited about it, I mean, however much work you have, you won't feel it.
That's very encouraging.
Yes.
Very nice to hear. Now, in your situation, and you touched on this a little bit before, you're an international graduate student.
That's correct.
How has that affected your experience as a grad student?
So I got to witness how the university system works here, how the classes are conducted here, how teaching is done here. So there are some differences, there are some similarities. So I actually was a TA in Sri Lanka, and I was what we call a probationary lecturer in my university before coming here. So I had some teaching experience, which helped a lot when TAing here in the US. I've gained a lot of experience in teaching. One of the major differences in courses that I find here is almost all of the classes here requires you to write a project, a paper. I don't recall having to write a paper for a lot of classes I took in Sri Lanka. So that's something different that I experienced, which was when in my first semester, I found it a little bit difficult writing papers, but with time, I got the hang of it, and now I enjoy writing papers for classes. So the last semester, the semester before that, one of my professors asked us to write a paper, and I decided to write a paper on breeding predation. The professor has asked us to write a paper for 4 pages, and I have accidentally written a paper of 20-odd pages. So those things also happen. So as an international student, I got to experience how different the classes are. Also, I got to experience what society is here, how people enjoy their time, and I was very much a part of it. All my friends, they would ask me to join them, so we would go out and so I got to experience that part as well. So one thing that international students should always remember is you got to be aware of what the school requires you to do. It may be coursework. It may be some other paperwork that you need to do, which is very different from the other grad students. So you got to always keep in mind of the requirements that you need to do as an international grad student, because if not, it can get complicated. My advice to any international grad student is take out your handbook and read very thoroughly. I mean, I feel that I'm a better person, not a more knowledgeable person every day that I'm here.
Awesome. How did you end up deciding to come over here to the United States?
When I applied for my programs, I applied to 2 professors that I've done a lot of research on. So I've followed their research for some time, and I love what they did. So that's the first thing that I did. Secondly, I looked at the classes that were offered, and I found them to be very interesting. Thirdly, I looked at the department and the school, what they had. And based on all of those decisions, I thought this is going to be, these universities are going to be good for me, especially the research that my professors were doing. That's one of the most important things that I looked at.
Is there a lot of paleontology done in Sri Lanka?
No, unfortunately. So compared to other research, paleontology is not one of the sought after fields. I mean, we have we have good fossils. Like we have the oldest fossils we have are Jurassic. Then we have a very extensive Miocene deposit, and we have some Pleistocene stuff as well. But I worked on the Miocene of Sri Lanka, and so the paper I published in 2011 was, I believe, the first paper published on Sri Lanka's Miocene in 40 years. So
Wow.
there weren't a lot of work done on Miocene, but there are a lot of researchers working on the Jurassic and the Pleistocene.
Excellent. Well, it's great to hear that you're having such a great time with your graduate studies.
I am.
I like to hear from people.
I really am enjoying my stay here.
You haven't been scared away from graduate school, and you haven't been scared out of the United States. These are all good things.
I was about to say, it's both admirable.
I love it here.
Wonderful. The other thing we've been asking our guests throughout this series, as we've said in the previous episodes, we decided to schedule these interviews over the summer, which means that it's been a little bit of a challenge getting hold of some people. So we've been asking our guests to talk about what they've been doing in the summer. And these episodes are being released in the order that we recorded them. And the reason that you are the fifth of 5 is because you were away for a huge chunk of the summer this year.
Yes, I was.
Can you tell us what has your summer consisted of?
Well, my summer was full of lab work. So before the summer started, I had a chance to sieve out my 10-liter bucket of shells. So I've been working in the lab, photographing almost all of my shells and digitally measuring them, trying to identify some of my shells. So it's been a lot of lab work, and some of my shells are like very plastic in their morphology, so it takes some time to identify them. And I've been looking for the presence of tracers. So my summer was full of lab work, but I did get a chance to go out with my brother, who lives close by now. So I got a chance to relax as well. But my summer was in the lab.
And we know you also went back home.
I was going to go back home, but it didn't work out well. So I'm planning, hopefully, to go back for a brief visit during the winter break.
I see. Okay.
Fun.
How often do you get to go back to Sri Lanka?
So I've not been to Sri Lanka since I arrived here in Missouri. So it's a long flight. So I imagine I'll try to go like once every year or so. It depends on the amount of work I'm doing. So
that makes sense.
It's one of those where my home's an 8-hour drive away, and it's tricky to work that in on a regular basis. I can only imagine a flight across the globe is a little tight sometimes to fit into the schedule.
Yeah, I mean, so when you go back home to Sri Lanka, like you got so it takes about 2 days to go, and we also have. I would probably have jet lag for about a week or so.
Yeah.
So that's a big chunk that goes away. So yeah, so it is really difficult to plan. In my case, I'm known to be very bad at balancing work stuff with other relaxing stuff because my work relaxes me. So yeah.
Whenever it comes up, you're like, no, I'm good.
Yeah.
Nice. Well, good luck with the future trip.
Thank you.
Now, when you're doing this lab work that you spend your summer and all of your other seasons doing, you're sifting through, you're looking at stuff under the microscope. Do you keep yourself occupied in any other ways while you're doing that? Some people, everyone has a way that they sort of make their lab comfortable for themselves while they're doing tedious sciencey work.
Well, I don't know if you guys would believe me. I do listen to the Common Descent podcast while I'm working.
That is not only what we like to hear, but what I was hoping your answer was.
I've learned a lot from the podcast, to be honest, like the episode on grass. So that's something that like we don't actually think about a lot about grass, but
us either.
Yeah, as animal workers, as if I may label myself. So I learned a lot from listening to the Common Descent podcast, and try to take frequent breaks while I'm working on the microscope because it's important too.
Yeah.
So basically, I've listened to podcasts like yours whilst I'm working. That makes me comfortable. And I had my headphones on me, so most of the times someone would come behind and spook me as well. So.
You get that adrenaline back up.
Yeah, you gotta wake up from all that staring at shells.
Yes.
Ranjeev, we have had a great time talking with you on this episode. If our listeners want to find or follow you, where might they find you on the internet?
Can always find me I have a Twitter account. Frequently update my ResearchGate profile as well. So I have my profile in my university. So if anyone's interested in contacting me or finding out what things I'm doing.
Excellent. We'll put links to all that in the description of this episode. Dear listeners, we hope you have had a wonderful time listening to our discussion with Ranjeev, as well as the other discussions in the Spotlight series. This is part 5 of 5. It's the end of the series. We hope that you had a great time meeting these paleontologists we've spoken to. We have had a wonderful time all 5 times, including this one with Ranjeev. If this is something you like, let us know. We will do this again. We will do more. We'll do another Spotlight series with another theme. Let us know. We've been very happy to see how enthusiastic our guests have been to talk with us.
Yes, it's been a lot of fun.
I would like to thank you guys for having me in this episode, and I would like to also suggest a survey about brachiopods versus bivalves as well.
I did have that thought. I was gonna mention that before we stopped recording because I did have that thought when you were talking about it. I was like, that it would be fun to have a side poll.
Well, tell you what, after this episode goes up at the end of September, we will put up a poll. Once again, we'll put polls up on the social media.
Yes.
And we'll direct people to this episode and to Alicia's episode. And we will see if we can convince some people one way or the other. So keep an eye out for that, folks. Check us out on Twitter, Facebook, and look for those polls, bivalves versus brachiopods. I'm gonna have to think about this one. I don't know if I'm on a side yet.
Bivalves.
I'm pretty sure I know which side I'm gonna fall on, but I'm not gonna announce it here.
I do like eating bivalves. This is true. We'll see. Thank you to all our listeners for joining us on this series. Thank you again to Ranjeev.
Thank you very much.
We are honored to have you tell us all about your research and such. And with that, we bring our Spotlight series to a close. Hopefully, we'll be back again with more of this. And regardless, we'll be back with more other stuff in the future. We now return you to your regularly scheduled series of podcasts. Goodbye for now, everybody.
Thanks for joining us, everyone. We'll see you.
Thanks for listening to the Common Descent podcast. You can follow us on Facebook, Twitter, YouTube, and check our WordPress blog for pictures and links after each episode. Huge thanks to our patrons whose support helps keep this podcast running and who get access to bonus goodies on Patreon. The song you're hearing is called On the Origin of Species by Protodome, which we found at ocremix.org. Thanks again for listening. We hope you'll join us next time.